Hello and welcome to section 1.3 on exponents, roots, and order of operations. Again, we're going to start with definitions. We're going to start with the definition of factor. We need to know what factors are, and factors are numbers, variables, values that are multiplied. So essentially, things that are multiplied are factors. A real quick example of some factors. Like 6x is 2 factors. Those are things that are multiplied. X times y times z are factors. Okay? So anything that's multiplied together, those are factors. 2x times the quantity 5y. Okay? Actually, again, we have 4 factors there. Okay? So those are factors. Exponents. Exponents, that's a product of repeated factors. Okay, this exponential notation I have down here in green, the base is base A, and n is the exponent or the power. So for example, if we have something that's 2 to the 5th power, we're repeating 2 5 times in a row. 2 times 2 times 2 times 2 times 2 is 32, or 2 to the 5th power is 32. Now, I'm going to skip down to the black here. Something to be careful of is what is the exponent really imposing itself on? Here we have the opposite of a raised to the n power. Well, we're only imposing the exponent on the a, not on the opposite, not on the negative sign. Okay, versus the opposite of a to the n. Now here we are imposing that n on the negative sign. Okay, so for example, if we have the opposite of 2 to the 4th, that's really what this is. This isn't negative 2 to the 4th power. The one over here on the right is negative 2 to the 4th power. This is the opposite of 2 to the 4th, all in how you say it. So it's the repeat is 2, 2 times 2 times 2 times 2, and then the opposite of all that. So 16 and the opposite of 16, so that's our final answer. So here on the left, we're only imposing the power on the 2, not on the negative sign. Whereas here on the right, now we are taking negative 2 4 times in a row. We're repeating negative 2. Negative 2 times negative 2 times negative 2 times negative 2. Or as I like to say, we're taking 4 negative signs and repeating, multiplying 2 4 times as well. So either way, you're still going to get you've got an even number here, an even exponent, so you've got an even number of negatives. So we get 16, a positive 16. So just be careful, the difference between the opposite of a to the n power versus the opposite of a to the nth power. Know what's happening there. We're going to move on to square roots and perfect squares. I'll expect you to be familiar with perfect squares. The column right here, the 1, the 4, the 9, the 16, those numbers are perfect squares. And those are numbers that are easy to take the square root of. Okay? So probably the sneakiest one is 1. 1 squared is equal to 1. Therefore, the square root of 1 is 1. It turns out that 1 is a perfect square. So 2 squared is 4. So the square root of 4 is 2. 4 is our perfect square. 9 is a perfect square. 16 is a perfect square. So 25, 36, 49, 64, 81, 100, even 121. 11 squared equals 121. So the square root of 121 equals 11. So I will expect you to know all of these. Commit these to memory, these perfect squares. 12 squared, 13 squared, 15 squared, 20 squared, and of course if you can do 20 squared, you can do 30 squared, and so on. And finally, your order of operations. Pemdas, or as you know, please excuse my dear Aunt Sally, when we have a complicated problem, we do what's in parentheses first, then we move on to exponents. We do multiplication and division. Now the order in here doesn't matter because remember our definition of division is multiplying by the reciprocal. So when we do multiplication and division, we just do those from left to right. we start with the leftmost multiplication or division and move from left to right. Then finally, at the end, we do our addition and subtraction. And keep in mind, subtraction may come before addition because subtraction is adding the opposite. So we do those left to right as well. So we'll move into some sample problems quickly here. So I'm starting with sample problem number 1. Negative 9 times negative 9 times negative 9. Well, we could also look at that. That's negative 9 to the third power. Negative times a negative times a negative, that's going to be a negative. 9 times 9 is 81. 81 times 9 is, and whatever we get for 81 times 9, 8 times 9 is 720. Is that 729? I think it is, and it's negative. Sample problem 2, negative 5 to the third. Again, we're taking 3 negative signs, so it's going to be negative. 5 times 5 is 25 times 5, so negative 5 times negative 5 times negative 5, okay, and that is going to be negative 125, okay. Sample problem 3, 4/5 all raised to the third power. So here we're going to, we remember our laws of exponents, we can cube each one of those. So we have 4 cubed, 4 times 4 times 4 is, 4 times 4 is 16 times 4. We get 64 over 125. Okay. Move on to sample problem number 4, negative 3 to the 6th power. I'm going to change this to negative 3 to the 4th power to make my life a little bit easier. Okay. Now we're not raising the negative to anything here, just the 3. This is the opposite of 3, all raised to the 4th power. So it's going to be a negative, and then we have 3 times 3 times 3 times 3. Okay, 3 times 3 is 9 times 9, and we get negative 81. Sample problem number 5, the square root of 100 divided by 121. Hopefully we recognize that those are both perfect squares. So that's the equivalent. We can take the square root of the numerator and the square root of the denominator. As such, the square root of 100 is 10. The square root of 121 is 11. So 10 over 11. Sample problem 6, the square root of negative 36. Well, because we're taking the square root, even though 36 looks like a perfect square, it is, but negative 36 is not. So this one is no solution. Those of you guys that know imaginary numbers will recognize that as being imaginary. Okay? Sample problem number 7. We've got absolute value here. Those aren't parentheses, it's absolute value. So, but we treat the absolute value bars like parentheses. So I'm just going to copy down the 6. The absolute value of 4 minus 5 is the absolute value of negative 1 minus 24 divided by 3. So that's 6 times the absolute value of negative 1, which is 6 times 1, minus 24 divided by 3. So 6 times 1 is 6, minus 24 divided by 3. Now we need to be careful here. Watch your order of operations. 6 minus 24, yes, that's negative 18, but that violates the order of operations. We have to do division and multiplication before we do any addition and subtraction. So 24 divided by 3 is 8. So we get 6 minus 8, which is negative 2, is our final answer. Okay? Sample problem number 8. I think our final sample problem here. We have a big fraction, we've got some multiplication, we've got some exponents. Okay? So, and it's the quantity of the numerator over the denominator. Let's work with -3, or 3 times -4, that's -12, plus 5 times 8. That is going to be plus, because that's a positive 40. All over 2 to the third is 8, minus 2, minus 6. So -12 minus 4 plus 40 is a positive 28 in our numerator, all divided by 8 minus 2 minus 6. Wait a minute, that's 8 minus 8. That's 28 over 0, which is 28 over 0. 0 is underneath, so this answer is undefined. Let's go back to that for you. That answer is undefined. That wraps up section 1.3 on exponents, roots, and order of operations, and we will see you in class.